Hello guys, so we continue from the previous recording, which was about introducing new features on the thumbnail generator, like common elements that you could reuse and inherit from. And so I have prepared a thumbnail here for the video, which was the one before that, yes. And I was thinking that this was a good opportunity to show you how we could now use this SVG generator mechanism. What I would like to do, in fact, here is to introduce a specific SVG effect to display kind of small lines, basically, around the draw SVG2 text here to kind of highlight this text. I guess it's a bit tricky to see what I mean, but yeah, just lines like shining effect. I don't know. So let's see how we can try to implement that with SVG. Where should I start? This recording is going to be maybe a bit slow because I need to think at the same time what I'm going to do, and I have not planned what the implementation is going to be. So let's see. First, probably we need something in the SVG generator, a new function. Probably need a few default elements, so let's put that at the end of the file, and let's call that generate. I have no idea what this effect is really called in English or even in French, in fact. So not sure. Let's just go with generate highlight, and eventually, if I find a better name, I can still change that. So generate highlight. SVG highlight. Highlight lines. All right, what do we need? The way I see it, what you need is basically you're going to define a rectangular area, so you need the width and the height of this area, and this is going to be the external side of your lines, and then you can apply some kind of scaling effect. So you would define on this rectangular area multiple points, and then you can apply a scaling effect to reduce the size of this rectangle, and at the same time apply the same scaling effect to all your points. So those points that were on the outside rectangle would move with the inner rectangle also, which is smaller. And next, you could imagine that you link those points between the initial version and the scaled down version. So if you do that, taking 2 points every time, so the initial one and the scaled down version, you can draw a line between those two, and this should give you some kind of effect of highlight effect of the center area. That's the idea I have in mind, so I need to try to build something like that. The scale, I don't think this would be necessary because we would need to specify the size we want. So for now, let's just say we don't have a scale, but we need some kind of width. So let's say rect width, and that would be SVG. I mean, we're going to provide an SVG size, so we can just retrieve the size this way, I guess. And considering this, we could also just as well provide the scale and set this to 1 by default, and that would be, so let's say SVG That would be the size first. Okay, now you can retrieve the width of your rectangle. That's going to be your size element 0 multiplied by the scale, and also the height. That's the size element 1 multiplied by the scale. Yeah, you need also another scale element which gives you the ratio for your effect. So let's call that ratio, I guess. All right. And we will need some colors and a stroke width also. So we need to keep SW, the stroke color. That's basically all we need for now because we're not filling anything. So probably no need for a fill color. And padding, I think we can still use that if we want to not yeah, allow some space around those rays. So let's keep padding in the X and Y directions. So with that, we can compute the full size of the drawing we want to do. We want to do drawing like that and compute the size. I mean, compute the size. We already have the size. That's the width and height value. That's the full size. So let's say, yeah, you don't need all of that. In fact, let's just say you want a drawing with width and height. The origin, let's say it's a top left corner, so that's going to be 0, 0. Okay. And now what do we need to do? We need to prepare the list of points that we're going to draw. So let's say we have points. I mean, that's going to be the start points, not the end points. So let's say start points. And that's going to be simply a list for now. And we're going to iterate on the width of the rectangle, and we cut that with a given number of steps. So we need actually the number of steps. So let's say X steps. That's going to be in the description. That's going num X steps. And probably we need also the same thing for the Y direction. Y steps. So the complete length of your rectangle is width, and you want to have X steps. So the delta X is, so this width divided by, let me think, if you have 2 points, it's -1. So that's X step -1. And actually, this should be an integer value, so we ensure that we are providing integers. And you're going to have the same thing for the y-axis. So you divide the height of your area by the y steps -1. So if you have 2 steps, for instance, your delta is going to be the full length of the height. Okay, if you have 3 steps, 1 at the top, 1 at the middle, 1 at the end, so you get the total height of your rectangle divided by 2. So this is consistent. Next, you want to iterate on this number of steps and add those start points. So for I in the range, how many steps do we have? X steps. So what do? You add a point. What is going to be this point? This point is going to be, let's not think about the padding for now. Point is going to be, let's say, build that as a tuple, delta x multiplied by I, which is the index, num point, if num point is 2, you have 0 and then 1. Okay, so that's covering all the complete distance. Okay, and then for the y position, currently I'm considering only the top of the rectangle. 10 minutes already, oh man. So if you consider only the top of the rectangle, the coordinate is simply 0. So you have this point and you need to add that into the list of start points. So I don't really need to write that here. I can just do start points happen this object. And this is for the top line, but we also need to do the same thing for the bottom line. So you're going to do the same thing like that, but this time the coordinate on your grid is your total height, or the height value. So this is covering the wedge of the rectangle. Now we need also to cover the points on the height of the rectangle on the left side and the right side. So we need to do another for loop because we don't have the same number of steps. I guess we could also have build this to have a consistent number of steps, but yeah, that's just one way of doing it. You should probably find infinite number of ways to do it. So what do? We do something like this one, except that this time we're going to start with the x coordinate always at 0 for the left side of your SVG canvas, and for the y you are doing dy multiplied by the I coordinate here. Okay, and I'm missing one parenthesis. Okay, and we do the next thing on the right side. So this is at the wedge position or the x coordinate. Okay, so that's all the start points that we need to deal with. Now we need to scale this down to produce a list of endpoints. For this, we can just iterate on every point that we have in the start points list. So in start points, what do you do with that? You are going to subtract. Basically, you want to scale compared to the center of your rectangle. So you need to have the center coordinates. You're going to do your position, any position that you have, minus the center, so you get a vector. This vector, you're going to scale it down, and then you add that back to the center position to get your final position. Basic 2D projection stuff. What did I say? So vec, let's just call that vec. Vector is this, what is a vector? It's the position that we have x coordinate minus the center x coordinate, which divided by 2. And the same thing for the y coordinate minus the 8 coordinate divided by 2. So this is the vector that you want to scale down by your ratio, which is provided here. So you can just as well do it here, in fact. So this part, we are going, come on, to multiply by the ratio. I would expect the ratio to be a value smaller than 1. So typically, I don't know, 0.7, 8, or even 9, I don't know. We'll try a few different things, we'll see. And actually, you could even try to, if you use a value bigger than 1, you're going actually outside of your SVG canvas, so you're not going to render anything this way. So you really want to have something smaller than 1. So that's your vector, and then you can add the center coordinate, and this is what you're going to push to your end vector endpoints. So let's say this is another tuple, and we're going to do vector 0 plus the center x coordinate, which is which divided by 2. And the other coordinate is vector 1 plus the height divided by 2. Okay, so now you have all the start and endpoints that you want to use to draw simple lines. So from that, you can just use a path to draw the thing. So let's copy this one, for instance. We will have a stroke width, okay, we will have a stroke color. A fill color, not really, we don't need that normally because we're just drawing separated lines, so there's nothing to fill. And then what you need to do is you just iterate, so for IDX and start point, as point in so you need to get the endpoint already. So for that, you just use the endpoints list at the same corresponding index, and you're going to first move to the start point and then draw a line to the endpoint. So what is the move command? It's something like that, yes, simply. So you move to start point. Come on, start point 0 and start point 1, and you draw a line to end point 0 and point 1, and you do that for every start point that you have, and ta-da, this is it, isn't it? Well, you still need to add this element to your canvas, otherwise it's not going to render anything, I think. Yeah, and at the end I just need to return this object, and it's going to be converted into an image and inserted into the thumbnail. Now, yeah, we're still not using the padding. Maybe we should try to use that already. The padding is something that is going to modify your x coordinate and y coordinate for your start point, right? So if you start here, for instance, the padding that you have, you're not really starting. Oh, and also the width that you're covering, yeah, you're actually covering the width minus twice the x padding, because you have to remove that on both sides. So padding x, and for the height of your rectangle, it's the same thing, minus twice the padding that you have on the y coordinate. And then when you start adding your points, you're going to add the padding to this coordinate, and same thing on the y, you will add the padding, so you replace 0 by the padding on the y, and next at the bottom you do padding x, and you add to this thing, and at the bottom you have to remove the padding on the y-axis. Okay, and here you start with padding x and you add the padding on the y. Come on. So you also add the padding on the y on here, and for the wedge the same thing. You go at wedge, but you remove padding on the x axis. Why do I put capitals? Alright, so now we're taking into consideration this padding. And we need to register this generation handler. not using the image, in fact, here. And so in the thumbnail, thumb generator, we're going to add a new generator here. Let's call that highlight lines. And it's in the SVG module, like that. And we need to kind of provide an initial definition for that in the common elements that we have. Let me find the file. So common. It's going to be something like that. So let's call that HL lines for highlight lines. It's a type. What's the type? It's highlight lines. This is what is used to find the appropriate generator in the list that we have here. So it's this name. And the base is going to be SVG base. It's providing an SVG size of auto. That's not quite what we want to have, because auto is not really used in this one. It will just fail. So you definitely want to override the default value. Let's say the default value we're going to use. Yeah, and if I use that, I actually need to get back to the generator, and when I read this, I need to ensure that I do the conversion with 2 pixel size, which means I need the image in the end. Yeah, so it's still the size 0, okay, multiply by the scale, and we need the image. And this one is going to be size 1, multiply by the scale. And now with this, we can specify string values for the size, and we can use percentages, and it's going to use the thumbnail size as a reference when you have percentages values. So it should be legit to use that. So what else do we need to provide as parameters? We have the scale, okay. We have the size already. The ratio, let's provide an appropriate default value. Let's say the ratio should be 0.8. Stroke width and stroke color, I think we already have those two. Yeah, so let's just remove that. Fill color, we're not going to use that. Padding, yeah. Scale, okay. And what else? The number of steps. Okay, num x steps, let's say 10 for start. And num y steps. I think it would be good if you could automatically compute the number of steps to have a similar resolution as on the which axis, the x-axis. But for now, let's just say we put that to 6. And that's it. Now we should be able to use this in, for instance, this one. So we have this draw SVG2. Let's duplicate this one, I mean part of it at least. So it's not going to be an image. So we don't want to provide any source here, but we want the base to be this. And just doing this thing, we have the, oh, maybe the size is going to be a problem, because if we are fitting the, yeah, on the y-axis, it's not going to match. But let's try and see what this is looking like already. Crossing our fingers. No error. Okay. And nothing displayed. Okay. So what's happening? Okay, let me try to think a little. Well, okay. Actually, it was a simple mistake. I forgot to introduce the. I think it's strange. I forgot to provide the SVG size, and as you can see here now, we have those lines drawing around. Not the most beautiful result for now, but we can tweak all this. I had also added some debug outputs. So you can see here I was trying to figure out how I was drawing the points, but I actually didn't really change anything in the code, I think. So yeah, it's just kind of working already. So we can just remove those outputs, and let's try to now tweak what we're going to display. First, the color. I think we can just change this to yellow for now, maybe. So struct color. I just keep default to white, but in our implementation, we just set that to yellow. And then we have, yeah, we need to make this bigger than the actual size that will be used for the, you can just make the size here bigger. So let's say 66. And this one, we can make it a bit smaller, like, I have no idea. That's the problem with this mechanism, is you don't really know what you're modifying until you check the result. Okay, you need this to be bigger on the X coordinate, and it actually became smaller. How could that be? Maybe because of the resize mode? I probably just want to use stretch here. Something like that, indeed. But yeah, probably I need to make the SVG which bigger to avoid those very long lines. So let's just make that to also 66. And if you make it bigger, it's going to compress the vertical lines, so maybe not so good idea either. So let's just reduce that. Still not really cool. Those are too long. I was hoping for something a bit different, actually. It's not really a ratio that I need to use, or I need a different ratio on the X and Y axis, I guess. Let me try to see if I can improve on that. Okay, so what I think I could do is I'm going to use a ratio to compute a variation of the distance that I want to see from the start point. But then I'm going to just use the same length for the ray, for all the rays. And so what I can do for that is just start from the start point, and instead of pre-computing the end point, I'm just moving toward the center of the rectangle using this ray size for every single ray. So this would give me the endpoint. So let's try to implement that, and I'm going, oh yeah, I guess I can continue this way. So when we have the ratio and the width and height, let's say we get some minimal value. So let's say ray length is a minimal value between which 8 multiplied by our ratio. So next we have all the start points, and it's not really needed in fact to compute the endpoints. You can do that basically dynamically. So yeah, let's just bypass that. Just skip the start point, and now when we have the start point, we also have the center point. Let's just say center is going to be which divided by 2 and 8 divided by 2. And now what do? You need to compute the direction of your vector. So it's a bit tricky because we're doing 2D computation here. So there is it's the endpoint is the center for us. So center 0 minus the start position and center 1 minus the start position. Oh, come on. 1. Now that you have direction, you need to normalize that and multiply by the ray length. So how do you normalize that? You get the length of this ray. So the length math sqrt of dir, oh come on, dir 0 times dir 0 plus okay, so that's the length of the vector. Now you just need to multiply the vector itself. To do that, we can just what did I put? I mean, I could probably just use a list instead. That will simplify a little bit my life. So for dir 0, you're going to multiply that by the length that you want for the ray, which is ray length divided by the actual length that you had before. Technically you could have cases where you have division by 0 and stuff like that here, but let's just not deal with that for now. So now you should your direction is the appropriate length to get you from your starting point to your end point. So what you need to do is you're going to move to start point 0 plus dir 0 and start point 1 plus dir 1. And here we go. We don't really need the ID anymore, so you can just iterate on the points like that. Here, redefinition. Let's call that the vector. Ah, come on. Yeah, okay. Or just vec, maybe. Okay. And now let's try that. I'll be back. Well, no, actually, this is kind of correct. It's all the rays have the same length, and what we have here is that we are actually reaching the center point because the rays are too long. And the reason why they are too long is because I'm not using the ratio appropriately. The ratio was normally the scaling ratio to get to your ending point, but here if I have a ratio of 0.8, what I'm doing here is taking 80% of the minimal length, which is pretty big already. What I want to do is in fact take, well, a very small ratio. So we can just change the logic that we have with the ratio, and you could say that instead it should be maybe 0.2, 0.15 here. Let's say that the default would be 0.2 here, and let's try again. That should be better. Yep. Yeah, not necessarily exactly what I was hoping for, but that's an interesting effect. I think I have too many of those steps here on the y-axis, so let's reduce this number a little bit. It's not here, it's here. Let's say 6, and also it's a bit too large, so let's say something like that maybe. And in fact it's the final size that need to be modified also. Yeah, I expected something a bit different, I guess. Okay, anyway, I think I'm not going much further than that this time. So let's call it a day on this attempt. If you have better idea on how you could implement this thing, let me know, or maybe you could give it a try if you feel like it. But I'm not sure I'm going to keep this one. I keep thinking a little bit, and if I cannot find an appropriate way to make it nicer, then I'll probably just remove that. But it was worth giving it a try, and now we have an additional generator here. Maybe this could be useful at some point. So thanks for watching. I hope you learned something, and see you next time. Bye bye.